Hello students, welcome to Solochem Lab. You have a 2021 UTME problem presented on the board to be solved. And the problem goes this way. In which of the following will an increase in pressure shift the equilibrium position to the left? And some reactions are given. Do not forget that pressure as a factor which affects the rate of a chemical reaction affects only species in gaseous form. So whenever you have a chemical equation which does not contain any species in gaseous form, pressure will not affect the rate of that reaction. Do you understand? Now, in a similar way, on the board, there must be at least one gaseous species in a particular chemical equation for pressure to affect the equilibrium position of that reaction. Again, for pressure to affect the position of equilibrium the position of equilibrium in a given reaction, the sum of the volume of reactants must be different from the sum of the volume of the products. What do I mean by that? Look at option A. We have hydrogen iodide. Hydrogen iodide, how many volumes? 2. This coefficient here implies 2 volumes. Hydrogen iodide is decomposed into hydrogen gas and iodine gas. The equation is balanced, as you can see. Now let's check the volumes of the reactant and species. The volume here is 2. What is the volume here? No coefficient is written here, so 1 is understood to be there. The same thing with this. 1 volume of hydrogen and 1 volume of iodine. So 1 plus 1 equals what? Equals 2. What about the volume of the reactants? What's the coefficient here? 2. Is there any difference in the volume of the reactants and the volume of the products? Therefore, a change in pressure will not affect the position of equilibrium in this option A. Do you understand? What about option B? Let's check the coefficients. The coefficient here is 2. What about the coefficient here? Is 1. 1 plus 2, 3 on the reactant side. Then on the product side, what's the coefficient? The coefficient is 2. Okay, so a change in pressure is going to affect the position of equilibrium. But how? How will a change in pressure affect the position of equilibrium? Look at the diagram on the board. This diagram is used to help us understand how a change in pressure will affect the position of equilibrium. If you have a piston here and you have a container like a beaker and you are trying to push down, you are trying to reduce the volume of the species in this container. This diagram is illustrating option C, where we have an oxide of nitrogen which decomposes to give us 2 volumes of nitrogen 4 oxide. That's what we're trying to explain here. The reactant has just 1 volume, N2O4, and the product has 2 volumes. That's why we wrote it 2 times. So when you are depressing, when you are pushing down the piston, this part is empty while this side is occupied. 2 times the volume of NO2 is 2 times the volume of N2O4. So when you are pushing down the piston, which species will the piston meet first? NO2. And when it meets them first, what will happen? It starts pushing them, it starts crowding them together. And when it starts crowding them, they will hit one another more often. And when they hit one another more often, the reaction will start. That means the position of equilibrium here in this problem, option C, is going to be shifted to the left. The position of equilibrium will shift to the left because the product particles will come together even before the piston meets N2O4. And when that happens, they will react to nullify the effect of increased pressure, thereby shifting the equilibrium position to the left. Is that clear? That means option C is the correct option because the problem says, in which of the following will an increase in pressure shift the equilibrium position to the left? And so we have understood it here. That's option C. That's the correct option. Using this illustration here. But for option B, an increase in pressure will shift the equilibrium position to the right because here we have 2 plus 1. That's 3. So when you replace these species here, the reactant species the volume they have is 3. They occupy more volume than the product species. So they will meet the piston first and start crowding up, start hitting one another more often, making the reaction to proceed in the forward direction, shifting the equilibrium position in the right-hand side, to the right-hand side. So this is not the correct option. Option B is not the correct option. And then let's look at option D. The coefficient here is 3, and the coefficient here is 1. 1 plus 3, 4. That means if you replace this option D in a beaker like this, the volume of the reactants is more than the volume of the product. That means the reactants will meet the piston first before it meets the products. And in that case, the reactants will start crowding up. They will start crowding before the piston will meet the products. That will shift the equilibrium position to the right, favoring forward reaction. And so this is not the correct option. Option C is the correct option. An increase in pressure will shift the equilibrium position to the left, this way, favoring reactant formation. And the illustration is given here. Do you understand? Do you have any question to ask? Do not forget to drop the question at the comment area of this video. And in case you want to talk with Solochem Lab one-on-one, you have an indication here. You have a contact here. For now, we will meet again in another class. Bye.